Good morning and welcome. This is going to be a test review of 9.1, 9.3, and 9.4. These are the concepts that will be covered on your test on Friday. Please be aware that any vocab that I have given you from these sections is also fair game, either to list, to fill in the blank, or to define a term. There is a section on that. So I'm going to start off nice and easy with 9.1. I highly recommend as you're listening that you would write the problem down, try to work it yourself. So feel free to pause and then see if you get it right, or you can follow along with me, whichever works best for you. So we're going to start off nice and easy by graphing. And my first example I'd like to use will be y equals negative x squared plus 5. So let's just go ahead and remember that when there are only two terms, an x squared term and an integer, that it's extremely simple to realize what our vertex is going to be. If you were to put 0 in for x, and we make our little table, and we were to put 0 in for x, we would get that y is equal to negative 5. Excuse me, positive 5. So this would be a negative 0 squared plus 5, which would give me a y value of 5. When we put 1 in, 2, negative 1, and negative 2. Please remember when you're placing a number in for the x squared to put it in parentheses. And those are our coordinates that we would go ahead and that we would graph. Now please remember, it's y equals negative x squared plus 5. There's a minus sign there. Remember, if a is positive, the graph opens up like a cup. If a is negative, the graph is going to open upside down like a frown. So I'm ready to graph, and I graph my ordered pairs. 0, 5, 1, 4, 2, 1, negative 1, 4, negative 2, 1. And my graph is going to look something like that. Okay? Now the domain, each and every time, no matter what you graph, guys, is all real numbers. The domain and the range need to go in set builder notation. The range, when the graph is opening upside down, meaning that a is negative, in this case, the range will be y is less than or equal to the y coordinate of the vertex. So y is less than or equal to 5. Okay? So that's a nice simple one. Let's try one that maybe has a few more numbers in it and that's a little bit more involved. So let's look at something like this. Y equals x squared minus 4x plus 1. So my hint to you, when there are three terms, is I would find the axis of symmetry, which is x equals negative b over 2a, and then I would find my vertex, and that'll keep me from picking 5 points and then seeing if this curve is actually going to move or do I have to keep on picking. So we remembered what we did. We went ahead and we wrote the standard form of a quadratic equation right above this. Y equals ax squared plus bx plus c. That would give me a 1 and a negative 4. So x equals negative b over 2a. Remember, the negative sign is part of your formula. So x equals a negative 4 over 2 times 1, or 4 over 2, or x equals 2. So the axis of symmetry is x equals 2. Are you with me? Good. Now we're going to find the vertex. To find the vertex, we plug x equals 2 into the equation of y equals x squared minus 4x plus 1, and solve for y. The ordered pair x and y is your vertex. So my vertex is now 2, negative 3. So now I'm ready to go ahead and to graph. Remember, when you graph, you can graph your axis of symmetry first, and the axis of symmetry was x equals 2, and it gets graphed as a dotted line. My vertex was 2, negative 3, and I'm going to make that point right there. Now this makes my life really, really simple when I want to just pick a couple of points. So the best point I could pick here would be 0. Which would give me a y value of 1. So that is 2 units away from my axis of symmetry, which is 2. So let me go 2 units to the right and see what's happened. Let's put a 4 in there. 4 squared minus 4 times 4 plus 1 gives me a 1 also. And so my graph is going to look something like that. Now my U's not perfect, but I want you to be able to realize. So in this particular problem, look at all of the things that we were able to find. The axis of symmetry, the vertex, we graphed it. Now we should be able to state our domain and our range. Remember again that no matter what you graph, the domain is always all real numbers. The range, because the graph is opening up like a cup, is y is greater than or equal to the y value of my vertex. And my vertex again was 2, negative 3. So it's going to be y is greater than or equal to negative 3. Now the last thing that we need to answer is the graph at a minimum or a maximum value. And I think we can all tell that the graph is at a minimum because it's opening up like a cup. So what we have covered in 9.1 are the following concepts. We have covered graphing, finding the axis of symmetry, finding the vertex, stating the domain and the range, and deciding if it is at a minimum or a maximum value. Okay, 9.3. What I want us to be able to do in 9.3 is look at a graph, state the number of roots, and name the roots. So if I were to give you, let's give you 3 graphs. Here's graph A. Here's graph B. Let's fix that one. I don't like that guy. Give me 1 minute there. I hope that this is helpful to you guys to help you prepare for your test. There's graph A, there's graph B, and here is graph C. God bless you. Okay, so graph A. Graph A touches the x-axis at one place. It touches at one place right here, so it would have one root, and if it asked you to name it, it would be 0, 0. Are you with me? Graph B does not touch the x-axis at all, so there are no real roots. Remember, quadratic equations can have one root, two roots, or no real roots. And graph C touches the x-axis in two places. There are two roots, and if we were to name them, they would be -2 and +2. That is what you need to know from 9.3. 9.4, we talked about solving quadratic equations, and I'm going to abbreviate it as QE, by the square root property and by factoring. And remember, along with the factoring goes the zipper. Okay, so we'll start off nice and easy. If I were to say, solve x squared equals 100. That is my original equation. To undo something that is squared, we take the square root of each side. When I take the square root of x squared, I get x. I'm going to give you an asterisk. When you take the square root of a number, you must include the plus and minus. So we're going to take positive and the plus and minus square root of 100, which we all know is plus and minus 10. And our answer can go in step builder notation. Let's try another one. How about m squared equals 44. M squared equals 44. So we're going to take the square root of m squared. We're going to take plus and minus the square root of 44, and we're going to remember that we must simplify the radical. Simplify the radical. So this is going to become m equals plus and minus the square root of 44 breaks down to 4 times 11, and 4 breaks down to 2 times 2. So this would be m equals plus and minus 2 radical 11. What happens if I give you something like this? M minus 2 quantity squared equals 5. So we're going to take the square root of each side. And we get m minus 2 equals plus and minus radical 5. We want to isolate m. So we add 2 to each side. And we get 2 plus and minus radical 5 as our answer. And the last one I just want to talk to you about briefly is factoring / zipper. So if I gave you one that looked like x squared plus 5x plus 6 equals 0, we're going to go ahead and use our x factor, what multiplies to 6 and adds to 5, 2 and 3. That is not the solution. Remember, your solution, once you zipper it, is the opposite sign of what is in the arms of your x. So your actual solution here is going to be -2 and negative 3. Then we want to look at what happens if we have something like x squared minus 64 equals 0. That's a special case. Please remember that is factoring the difference of squares. And that would factor as x plus 8 times x minus 8 equals 0. Now when we go ahead and zipper that, we get x plus 8 equals 0, x minus 8 equals 0, and we get two solutions. We get a positive 8 and a negative 8. And that can go in your set builders as plus and minus 8. Okay, so please remember, don't flip out if you see a fraction or something like that, because you can handle that. If I gave you 1/4 x squared minus 25 equals 0. 1/4 is a perfect square. It would factor as 1/2 x and 1/2 x. And this would be plus 5 and minus 5. And then we're going to take it and we're going to zipper it from here. Okay? So we subtract 5 and we get 1/2 x equals negative 5. Multiply each side by 2. So x is going to equal negative 10. And positive 10. Okay, that concludes our review for today. I'm going to put this up on YouTube. I hope that helps you guys. And tomorrow I'll go ahead and do specific questions and post them on a review as well. Have a blessed day.